All right, so let's try this again. I know last time wasn't good quality, so we'll try a different method. So here we have another linear momentum problem. We have two objects and they have the same mass, right? So this is mass m. This would also be mass m. They're not like different numbers, they're the same numbers. This will be important. So we have a before instance. This one has an initial velocity of 5 meters per second. This is sort of, you could call this the VIX. And this one, all that it is moving 5 meters per second. It is striking the rear end of this object Y, which is moving slower. It is moving, first one moving 5, slow one is moving 2 meters per second. So we'll, just like you're rear-ending someone else's car, this will strike the rear end of here. And then this one will transfer some of its momentum and kinetic energy to this object Y. So object X then slows down, we're told, and object X afterwards has the 2 meter per second speed after. Object Y will have the 5 meters per second after. Right? So after this will be now going quickly, and this will be going slowly. And say 2, this will be going at 5. So it's asking what will stay the same, what will change. So we know that in terms of our P, the P total will always be equal to just the momentum of the two parts. So my momentum in X plus my momentum in Y. So momentum in Y added together. Both of these numbers will be the mass times the velocity of the respective objects. This will be m v x for both of these. This will be m v y for both of these. V to the v, and it's a y. These two terms are added together. Now, very important, the masses are going to stay the same, right? So really this mx and my, we just call that m. You know, it's going to be some constant number, 1, 2, whatever. Then we can even take it out. M, then for my Vx initial and Vi initial, those are just swapping places we saw, right? So this will then turn into 2 plus 5 for my velocities, whereas afterwards, you know, commutative property, this will be 5 plus 2. Seem to have mixed myself up here because I associate the x with the 2. So this will be P final, this will be P initial. So notice that it will really be just the same for both. You really don't need to think about the math too hard here. Just know that, yeah, when you flip around numbers, right, when you're multiplying or adding, the order doesn't matter. So we definitely know that this P will remain constant. And because the M is constant, right, we can apply this same logic with the K. And I'm going to give you guys a chance to think about it and do it out. Just remembering that the K initial and the K final will be equal to this equation will be the 1/2 and then mv squared of one object plus the 1/2 mv squared of the other. So this will be mx vx plus, and I'm going to write this below, the 1/2 my vy. Again, we are just going to switch the numbers around. And because this m is the same, and because of this nice commutative property here, we would see that the k also is going to stay the same. So our answer in this case will just be A. All right. Thank you. Have a nice day, hopefully.